Don't mind me and my porridge. Okay, so what lesson are we starting with in the physics? What's the first one we have to... Huh? Rocket science. There was nothing before that?
Yep.
Okay. So tell me, which question are we starting with in rocket science? Number 2? Can you see? Great. Okay. KJ, can you read number 2 to me, please?
Okay. First of, a cat first of all looks that is 5 meters high.
Ah, is this rocket science?
Yes.
I had a okay, no, I understand now. Cat question,
Yeah,
yes.
I feel better I this one.
Okay, right, hang on, let me just draw this. So, a cat falls off a roof, right?
So it's 5 meters high.
Okay, 5 meters high.
The cat has a mass of 5.5 kilograms.
5.5 kilograms.
And the cat, then she bends her knees to soften the shock of landing. This bending
Spider cat. Go on.
The bending of the knees lasts 250 milliseconds.
Yeah.
How much force is fed by the cat in the landing?
Okay. First thing I want to do is I want to know how fast the cat is going when it hits the ground. UVATS. Let me open up the calculator. Zero, don't know. Minus 9.81, don't know. Minus 5. V squared equals U squared plus 2AS. No. Yes. Yes. 2AS. That's right, isn't it? I don't know. 2 times A times S is 98.1. Yeah. So V is the square root of 98.1. Yeah, you have it?
9.905.
Okay. With a minus because the cat's heading down. So what's happening here is, if we now look at this part, the cat is going from minus 9.905 to 0. So there's a change in the cat's momentum from mv minus mu, which is 0 minus 5.5 times minus 9.905. What is that?
54.475.
If I divide this by the time that it takes to do that, then what I've figured out is the force on the cat, the total force. So what's that? 200 and something. 217? 0.8 newtons. Now, I think the question said, what is the force experienced by the cat?
Yeah.
This means, what does the cat feel when it hits the ground? This means, what is the reaction force between the cat and the ground? So when you look at the picture, this 217.8 pointing up or down?
Up.
Yeah, because when the cat hits the ground, the force is upwards, causing it to slow down. But that total force is made up of two forces, the reaction and the weight. So this 217.8 equals the reaction minus the weight. So the reaction is what we care about, which is 217.8 plus W. So that's 217.8. What's the cat's mass? 5.5. So what does that become then? Point. Just 271?
No. 271.8.
271.8? How's that one, KJ? You don't like it?
Well, can you explain me?
Yeah.
What are you like?
What's what?
217.8
Yeah.
equals I minus 3.
Equals or?
I minus 3. Yes, yes.
Oh, this? Yeah, because this formula here comes from Newton's second law, and this is for the total force. So the F total is 217, but the total force is equal to this minus this, because there's two forces making the total.
Oh, okay.
Yeah. Tell me, KJ, after a few seconds when the cat is fully stopped and at rest, what's the F total?
0.
Yeah, 0. So it's only for this amount of time that the cat has this reaction force, because then afterwards it would just become this. So it's like the cat has this much extra force in its legs it feels when it hits the ground. Bruce?
No.
Not Bruce? Then don't answer. Hard question? Easy question? Confusing question? Not confusing. Was anybody able to get it? Yeah. I suppose there's probably another rocket science question to do. How many are those?
5.
How many questions do I have altogether?
5.
3
3,
more.
4, the answer is
3
a
A
little.
little strange. Okay, alright. Let's do some more. After the rocket science, what else is there to see?
Cantilever.
Cantilever?
Yes.
Really? No. Did you watch the videos?
But
No, I'd like if you try to watch the videos, and then if you don't understand, I can do it. Did you watch the video? Did you say you don't want to watch the video?
He understands without the video.
Okay. Alright. Well, anyways, let's do more rocket science, and then we'll look at what else there is to do. Oh, sorry, do you have this written down? Do you have this? Yeah? Okay. Right, so what's the next question then to do? What number?
3.
3.
3, 4, 5.
Oh, no, please. Okay.
Yeah.
Chrissy, give me number 3's information, please. What's the story in it?
182 centimeters tall, 50 centimeters wide, and 100 kilograms.
Okay, I know this one. So this is the person. Okay. How tall did you say he was? 182 centimeters. And how wide? 50 centimeters. And it's a 100 kg. Okay. Speed 1 meter per second, huh?
Yeah.
Yeah, okay. And the wind?
20 meters per second.
Now, first thing is I want you all to understand that this is the same problem as this. I wonder if somebody can tell me why that is.
Why?
Yeah, tell me.
Because
Because the 20
each other.
Basically, if you're walking into the wind at 1 and the wind's blowing to you at 20, it's like the same thing as you not moving and the wind's blowing at you 21. Because, think about it like this. If there's no wind and you're walking at 1 meter per second, that's the same thing as if you're at rest and then there's wind blowing into you at 1 meter per second. Because in both cases you hit the air at 1 meter per second. You cut the air at this speed. So we're allowed, if we want, to change this problem into this problem, which is actually easier if he's not moving. So that's the first thing. Now, are you okay with that idea?
Yeah.
Yeah. So I am going to rechange this problem then into the wind is blowing at 21 meters per second. So in a time of 1 second, we only need to look at 21 meters of air in front of him. Okay, and what am I looking for here, Chrissy? What's the question want?
How much force does the teacher bear from the wind?
Okay, so we know force is the change in momentum of the change in time. So the force the teacher feels is going to be the air is going to come to him and hit him. The force he feels is equal to the force the air exerts on him. So how much force is this? Well, the air is changing its momentum. Here it's blowing to him, and then when it hits him, it comes to rest. You know, the air blows into him, hits him, and then comes to rest because he blocks it. So it's mv minus mu over t. We're saying the t is for these problems for 1 second.
Oh, why?
Why 1?
Oh, yeah.
Because for these problems we always look at what happens in 1 second, because all of these are per second. Yeah, so the wind is 21 meters per second. His speed is 1 meter per second. You know, we're looking at the force per second because it keeps happening every second. It's not like the cat example. In the cat example, the time was 0.25 seconds because that's how long the story runs for. But this run runs every second. Every second there's another 21 meters. Yeah. Okay, so this one here is 0 minus mu, which is minus 21u. So all there's left to find... No, that's wrong. What am I doing? The u is 21. Minus 21m. Yeah? Now, just before I go back here, all the way here... Whoa. Okay, so the air is moving and the force we just worked out is a minus 21m. So there's a reaction here between the air and the man, so that reaction will equal 21m. It's just the opposite sign. So the force experienced by the man, which is the reaction force, will just be 21m. Now, if we use density as mass over volume, then this will be 21 density by volume. Now, do I tell you the density of air in this question? 1.225 times 21 times 0.5 times 1.82. Okay, what's that, please? They're being lazy, thank you. Yep. Only 23.41? No, I would have thought it's... Did you multiply this by 21 twice?
Oh, twice.
Yeah, can you see 21 here?
491.
4.
91.6 is 0.
What is that number from? 21 or 5?
Yeah, 0.58, 1.82.
Ah, volume. Let me think here. I'm going to add in a bonus extra part. Bonus. What angle does the man make with the ground? What angle does he make with the ground? No.
Angle.
Yep.
Oh,
Not 90. Think about this in real life. When you're walking through the wind, are you at 90 degrees to the ground?
No.
No. Would you be more or less than 90?
Left.
Less. Maybe something like this. Because you're leaning into the wind. Yes? Now, why is that? Yeah, naturally we do it to make it easier for us. But let's calculate the angle he makes with the ground. Yes? I know, it's interesting. You think it's... Yeah. 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 Can I look at it? Okay, so let's just draw the picture. And remember, in this picture the man isn't moving. Okay? He's not moving in the way we drew it. So there's a wind here. So what's the force here from the wind? We said 6 newtons. Yeah? So he must be applying a force this way. Yes? If he didn't apply this force, let me just draw this a bit more, sorry. And there's a weight here. What's his mass? 100 G. And then there's a reaction force here. Yeah? Actually, let's think about this.
You have three force, no force.
Does he have to exert a force more than that of the wind?
No, I tell you actually, sorry, what's happening here, I drew this a bit wrong. How tall is he? He's 180, isn't he?
182.
182. So here, this wind will be in the middle. So if he's 182, that's 91, isn't it? And this is, what did I say? 4.6 newtons then. Okay. This is 100 G. This is the reaction. Yes. The force going forward, where does it come from for the man? What makes him go forward? Where does he get this force from? From his foot, yeah. So on the picture, I should draw the force here from his foot like this. And what should that equal? That should equal 491.6, right? But there's a problem with that. Because if you look at the picture, the R cancels with the 100G, the F cancels with the 491, but that doesn't mean he doesn't move, because we have a turning force here. If you look here, we have a force this way, a force this way. If we use this as the turning point, then what do we have here? A clockwise or an anti-clockwise? This will be clockwise, and this one here doesn't have any effect because this is the turning point. So what will happen to the man? He'll want to fall backwards. So how can he fix this problem? He leans forward. Not quite this much, but you get the idea. So now he still has the force from the wind, but he also has his weight acting down as well. this is a clockwise and this is an anti-clockwise. So he's going to try and use his weight to be a anti-clockwise force to stop him falling backwards from the clockwise. So we have to draw the picture very carefully here. So this is my man as a stick. And this is his weight, which is 100 G. And remember, we said the wind acts in the middle. So that's, what's that, 91? No, what's, no, not quite actually, because his height is now less, because he's at an angle. So if this is 1.82, and this is theta, then this length here would be 1.82 sine theta. That's the height. So the wind acts in the middle of this over 2. Will that be above or below this point? Should be at this point. Oh, no, I'm doing something wrong here. Okay, this question, I made it too hard now. Let's forget about it. I need to think about it. Okay, what's the next question then? The answer's wrong? Are you sure? Are you sure? You watched my video?
Every time I
Okay. Give me the information, Jerry.
This 5 rockets during stage 1 of this flight reduced its mass from 2.3 million kilogram to 0.48 million kilogram over time of 2 minutes and 42 seconds, like burning off the fuel known as this type of
Great. Keep going.
this fuel is injected, is released at a speed of 3124 meters per second. What is the
Trust, is it?
Approximately.
Good. Good. So the question here is, am I looking for the the thrust, is it? Or what was I looking for? The what did the question ask me to find at the end there, Andrew?
Average upward acceleration.
The acceleration. Okay. Newton said F equals ma. So that means A equals F over m, which equals T minus W over m. Yeah? Now the T, we have the formula for this, it's just the mass of the gas that comes out per second times the velocity per second minus the weight of the rocket all over the mass of the rocket. Now we have some problems here. The mass of the rocket changes from this to this. So what do we do if it changes? What should we use?
Average.
We should use the average. So that will be over 2 times 10 to the 6 2.3, so that's 2.78 over 2. That would be the average. 2.78 over 2 times 10 to the 6. Now, this information we know here, we know, or we could know the mass of the gas per second. The mass of the gas per second is something we can work out. I'll just leave it blank there for the moment. And its speed is 3124. So let me see, that would be 162 seconds. And the mass of the gas per second, well, we need to work out how much gas came out and then divide it by the time. So that would be 10 to the 6 here, 2.38 minus 0.48. So that's 2 minus, so that's 1.82. Okay, so let's hit this into the calculator. 1.82 times 10 power 6 divided by 162 times 3124 minus 2.78 times 10 to the power of 6 over 2 times 9.81 times the 2 in the denominator divided by 2.78 divided by 9.81 divided by 10 to the power 6. Did I hit those in all right? 1.57. What's my answer at the back? 15. So I feel like I mistyped a decimal point somewhere. Is that possible? Of course it's possible. Of course it's possible. Let's go back. No, that was right. That was right. That was right. Is it 162? Yeah, 162. And it did say 2.3 million kilograms. Or million tons. Million kilograms. Huh? Yeah, kilograms. Okay, let's type in the full thing. Well, maybe my answer at the back is wrong.
No, it's correct.
Well, why is it wrong now? 1.82 times 10 power 6. Alright, that is the mass per second. Good.
Sure, I think 2.78 is wrong.
No, 2.78 over 2 is the over the 2, yeah. Syntax error. Interesting. What answer did you get, Jerry, when you thought I was wrong? And why did you get the same answer as me at the back? That's wrong. They both can't both be right.
Yeah, I watched the video, but I understand the whole video.
So what did I do wrong in the video? Or what did I do different in the video?
What did you do different here?
What do you get for T?
I didn't calculate the T. But you want me to calculate the T?
Yeah.
Okay. 1.82 times 10 power 6 times 3124 divided by 162. That number.
Yeah, correct. And then minus mg.
Okay, what did you get for mg?
I didn't calculate. 1.39 times 10 power 9.
Okay.
Power 6, sorry.
Ah, dude! Alright.
And times...
Wait, no, wait, I have to go back now.
Okay.
This was it here, wasn't it? Oh, flip.
Yes.
Let's start this again. What did you get for the trust? Read it out.
3.51
3.51.
times 10 power 7.
Okay. Minus
1.39 times 10 power 6 times 9.81. Yep, and then divided by n, 1.39 times 10 power 6.
This will look embarrassing for you if it's 1.5 and me. No. Okay. Alright, something's wrong somewhere. We can't get two different answers.
What is that 1.6?
That's how much mass was lost. That is, I hope, 2.3 minus 0.48. Very interesting. Something is wrong.
I use that R equal delta P over delta T equal 100.
Yeah, but what about the weight?
The weight? He gave us the weight. The first time is 2.3 meters per one, and The last is 0.4.
Okay.
The change is
I understand the change in the total mass from the start to the end.
yeah, we just use that I. We use I.
And what answer do you get if you do it that way?
I got 5.9.
5 or 15?
I'm wrong.
So now we have 3 answers. We have
Although I'm wrong, I know I'm wrong.
no, hang on. We have 3 answers: 1.5, 15, and 5. But I don't understand.
Get it. Why you come 9.8 one below it?
Yes, sorry. Thank you. The M. There's no G here. It's mass, not weight.
But you do get it.
No, but that means that's why my answer is 10 times too small.
Oh yeah. Oh yeah.
Oh, now it's all making sense. Oh. So, can I go back? Or it's gone now? It's gone. What did I get? It was something like 1.5, was it?
Yes, 1.5.
Something like that, yeah. But I shouldn't have divided by 9.81. Alright, let's do this again. 1.82 times 10 power 6 times 3124. Oh, rats, this is over 162 as well. Minus 2.78 times 10 power 6 over 2 times 9.81 over 2.78 over 2. Am I 10 to the 6? 15.4. Is that the answer at the back? Getting porridge on me. Alright, what's next? Not the next one as well, is it?
Yeah.
The long one.
5 inch. But you have to do the work. Wait a minute,
This is recording though.
He doesn't want you to.
Yeah. Did you subscribe on YouTube?
Sometimes.
It's just a long place.
Maybe he likes to subscribe and unsubscribe. Mess with my numbers.
Follow.
Okay, got this?
Well, why is that T equals
T equals W, what?
why R equals T minus
F is total force. Up minus down. Yeah? Total. Okay, can we do 5 now? Yep. Alright. Monica, go for it now.
A very small amateur rocket is at rest on a launch pad. The engine is off when T is less than 0. The mass of the rocket is 100 kg, 90% of which is fuel. And it ejects gas at a rate of 9 kg per second at a speed of 100 meters per second.
Okay.
This begins when the engine is fired up at T equals 0 and continues while T is greater than or equal to 0.
Cool. So what do I want for part A then?
What is the weight of the rocket before takeoff?
Okay. So the first thing, so before takeoff, the weight is going to be 100 G, which is 981 newtons, right? Now, B is what exactly now?
The reaction force of the rocket before takeoff.
Before takeoff. Now, before the rocket takes off, the weight and the reaction must equal, because it's not moving. And there's no force, no acceleration, nothing's happening. Okay, C.
What is the thrust at the moment the engines are fired up when T equals 0?
Okay, so when the engines are fired up, there's now an up force provided from the fuel, and that we know the formula is the mass of the fuel times the velocity of the fuel per second, which is 9 times 100, which is 900 newtons. Okay, next.
The reaction force at the moment the engines are fired up.
Okay, so we have our reaction force, and we have our 900 newtons, and we have our 981 newtons of weight. So then what must the reaction force be? Has to be 81 newtons. Okay.
Why doesn't the rocket take off?
Yeah, why doesn't the rocket take off now? Well, because 900 newtons, which is the force from the engine, is less than the weight by 81 newtons less. So the rocket doesn't move.
When will it take off to the nearest second?
So the rocket doesn't move at the beginning, but it will move soon, because as time passes, it's losing mass. So at some point the 900 newtons will be enough. When does 900 newtons equal the weight? Well, 900 divided by 9.81 equals m. What's that, please? It's about 91 kg. No?
91.74.
Yeah, about this. So if the rocket loses, how much per second? 10, was it?
9 kg.
9 kg per second. So roughly after 1 second, because after 1 second its mass is 91 kilograms, which is about enough for the rocket to start lifting off then. Okay, what's G then?
How long will the fuel last for?
Okay, well, how much fuel is there? 90 kilograms. And how much are you losing per second? 9. So the answer is 10 seconds. And then the fuel's gone. Yep.
What is the maximum height of the rocket, ignoring air friction to the nearest meter?
The juicy question. Juicy one. Right, okay. So let's have a recap here. I would like to know, this is thrust, this is weight. I'd like to know the acceleration here. So just like in the previous question, acceleration equals F over m, which equals T minus W over m, which will be that. Oh, well, actually, we know what it is. It's 900 newtons. But the problem is we don't know the mass because it changes. It goes from 100 at the beginning to 10 at the end. So it has an average mass of 55 kilograms. So what does this equal? .55. Yeah. So let's work out how fast the rocket is going after 10 seconds. So we have U equals 0, V what we want, A 6.55, T equals 10, and S equals something we want as well. So let's get V and S. So V equals U plus AT, yeah. So the V is 65.5, and the S equals UT plus a half AT. t squared, so that's 655 over 2, 327.5 meters per second. So after 10 seconds, the rocket is this high and going at this speed. This is how fast it's going, and this is how high it is. But of course, that's not the end of the story, because after 10 seconds, what happens? The engines turn off, but does it fall straight to Earth? No, what will happen? It will continue up for a little bit until, it comes to rest, and then it will fall back down. So now, if we look at this part, U is 65.5, V is 0, A is now minus 9.81, T we don't know, and S we would like to know. So S equals U, maybe we'll go with V squared. V squared equals U squared plus 2AS. So what's that, please? 65.5 squared over 19.62? Thank you. Plus 327.5. So the total height, when you add the two distances together, is 546 meters. Oh, I didn't realize this was an angle. No, I got it. It's okay. It's fine. Whoa. Try not to die. There we go. Good question, huh? Yeah. Oh, dang. Close enough. In real life, will it be more, less, or equal to this?
Less.
Why?
There is resistance.
Yeah. Really? Is that Bruce? Whoa, is that you, Bruce? What happened to you? That's not really an answer. Sit down. No, I was busy doing this question. You put the heater on, Chrissy?
Yeah.
Is it on? Okay, did you write this down? Yeah. Cantilever, I will not do today, because I will do it next week. I want to make sure everybody has tried it and watched the video.
There's no video for that.
You lie.
Sounds like.
You lie. I'm sure it's on my YouTube channel.
What is that? Because I followed the link and I saw nothing.
Yeah. I sent you the text when I uploaded it.
But the text is a bit close to one, right?
That's it.
How about this?
Check my YouTube channel.
Yeah, I checked. I can't find it.
Are you sure?
Yeah.
Don't unsubscribe just because you can't find it, okay? What I can do then is I could reprint out the worksheet because I have the links on it now.
Do you have answer as well?
And the answers now. Well, I reprint it then.
Thank
Yeah, okay, so in the next class then, I'll reprint it then. Yeah. Okay, so was it just the cantilevers then? Yeah. That it was only the cantilevers or the tree force? Those ones, the cantilevers.
You mean question?
Yeah.
Another question, principle of moment.
Principle of moments. Do you watch the video?
Yeah.
And?
Still don't get it.
Which question is it?
Number 2.
What's it about?
It's a bridge, 100 tons, 100 meter long,
Yeah.
and find the turning point.
Okay. So it's 100 tons, so that's 100,000 G. And how long is it? 100 meters? Oh, but this is the way I'm picturing it. And then I say the force which lifts the bridge acts 10 meters from the end. So this force here, which is 10F, must equal this force here, which is 50 times 100,000 G. So then the F would be 50 times 0000 times 9.81.
Yeah, I know the formula, but you ignore the angle. Because there's an angle in this picture.
Yeah, and it's being pulled up.
I didn't think the picture would be confusing, so...
Yeah, if it is straight line, then should be no problem with that.
I was trying to show you that the force could lift the bridge up. So, I suppose if you prefer, technically, if you want, I perhaps should say the force should be greater than or equal to this. So, I was looking for the minimum force that would lift it. Yeah? The picture confused you. If there was no picture, this would actually make it easier. Alright.
With the exam will be more like clear.
Mine is not clear.
No, I mean
No,
I
I
thought
take it back now.
I thought David's force is 0 and it was
Yeah, don't worry. The exam will be clear. Okay. Coffee break? Yeah. And then we'll start the next lesson then.